All right, so there's four transformations that we talked about. This is for our EOCT, and the topic this time is transformation. Okay. There's a question on transformations. There's the first type that we talked about is a translation. What's another word for a translation? Okay. The way you translate something is you slide it. Okay. What that means is a slide. And if you want to slide it to the right, which number do you change? X. So I change X. This goes right or left. What makes it go to the right when the number is? And it'll generally say something like X plus 2. And so that would be to the right 2. Or it'll say X minus 3. And that would be to the left 3. Okay. Then they'll go up and down. Again, up is positive, down is. Okay, so if I said Y plus 3, this would be to the right 2 and up 3. So you take that whole image and move it over and up. Or Y minus 5. And generally, they put them in to show you a different notation. And I think if you remember on the EOCT, they use the word vector. And that seemed to throw a couple of you off. That's all that means, is use those instead of the parentheses that you guys were used to seeing. But guys, it's the same thing. Whether that's a parenthesis or whether that's a greater than or less than, some, that's what they meant right there. Yeah. Yeah, that's it. All that is those brackets right there instead of parentheses. Okay. So anyway, translation is a slide. Rotating something is a turn. Okay. This is an important one, because this is one that you're going to have to be able to talk about tomorrow. Okay. There's the first thing that you need to make sure you, somewhere in there that you mention, is that you know the default way to turn. If you're not told which way to turn, you should assume they want you to turn counterclockwise. And the way you remember that is that you guys know that the quadrants are numbered counterclockwise. And that should remind you that in a standard, that you're just told to rotate it a certain amount of degrees. That's how you know where to, that's why you know to go counterclockwise. Now, you can be told to rotate it clockwise, or you can be told to rotate it 400 degrees. But generally, our starting point is, if you're not told, know that rotate it counterclockwise. And there's basically two rotations that, I got you, Steve. There are basically two rotations that we need to talk about. That's taking a point and rotating it 90 degrees. Okay, if I rotate it 90 degrees, then it maps to negative yx. Now, does that mean I can only move from the first quadrant to the second quadrant? No, guys, I could start anywhere. If I started here at negative 6, negative 5, I could rotate that thing negative 6, negative 5, 90 degrees. If I rotated it negative 6, negative 5, 90 degrees, this would be the negative of a negative 5. What is the negative of a negative 5? So that would rotate to 5, negative 6. So this point, if you think about this for a second, it makes logical sense. This point in the what quadrant? Third. This point in the third quadrant would get rotated 90 degrees, and it would send it over to the fourth quadrant. And that's a 90-degree rotation. So the next kind of rotation is a rotation of 180 degrees. So if I'm going to rotate something 180 degrees, it's going to go to both things being changed. So it goes to the opposite of where it is right now. So to take the point xy to the opposite of where it is right now, you take it to negative y, negative x. This seemed to be a This seemed to be an issue the other day when we were talking about this, because we wanted to use the word opposite for inverse. Remember, inverse means take the x and the y and switch their places. Okay, so these two are switched when you go yx. That's just the inverse. If you want to do the opposite of it, you have to take negative y, negative x, and that moves it 180 degrees around. Now, here's the one that was the one that separates the people that know what's going on from the people that don't know what's going on. When you do a 270-degree rotation. Guys, we don't have to memorize something for 270 degrees. What we do when we take something 270 degrees, we know that that's a 90-degree rotation to the right. Instead of having to go all the way around 90, 180, and then 90 more, we can just go 90 degrees the other way. We go 90 degrees the other way, I take 90 degrees right there, and then just go opposite that. So if I go 90 degrees, and then the opposite of it would be, the opposite of that would be positive y, negative x. So if I went positive y, negative x, that's 270 degrees. Think about that for a second. If I'm in the first quadrant, and I want to rotate something, what quadrant will I put it in? The fourth. If I'm in the first quadrant and I want to go 270 degrees around, I go all the way to the fourth quadrant. So the fourth, I don't go back to the first quadrant, because if I went back to the first quadrant, that would be 360. Am I good? And this is the same thing as a 90-degree rotation to the right. Okay, last one. Reflection. What's a reflection? It's a flip. Okay, dilation is when something gets bigger or smaller. You had a question a second ago. Go ahead. Yes. Okay, so a reflection. Give me some things that you're going to reflect stuff around. I could reflect it around the x-axis, origin. When I reflect something around the x-axis, what changes? The y changes, guys. So when I flip something around, here's the x-axis, the y value changes. Look, the x isn't changing. It stays on that vertical line. What axis is that? That's the x-axis. What is the equation of the x-axis? Y equals 0. Remember, it's y equals 0. So if I want to flip that thing across the x-axis, look, this guy right here is going to be the same distance on the other side, so it's going to stay on this vertical line. So as it flips across the x-axis, x doesn't change. Y changes. Now, logically, what does that mean when you flip around the y-axis? That's right, x changes. So, if I drew the y-axis in, the equation of the y-axis is x equals 0. So if I took a point right here and I flipped it over the y-axis, look, y wouldn't change. It would stay on the same y. What would change is this x value would become a negative x value, and it would flip over here. X changes. Now, on the test tomorrow, instead of doing a line y equals 0, it says the line y equals 3. The difference is, what you do is flip it like you're flipping it over y equals 3, and then just move it, or excuse me, y equals 0, and then just move it up 3. So if I wanted to take a point, here and flip it over that line right there, I could imagine that I'm flipping it over this line and then just move it up one. So the y here, the y changes or not? The y changes and then adds 1 to it, because instead of flipping it over the line y equals 0, I flip it over the line y equals 1, or y equals -1. You need to think about that logically. Again, these videos I'll put on my website just like I did with the final exam.